Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Kyle.
And in studio with us, we have Anjali. And Anjali, if somebody needed to call us or get a hold of us, what would they need to do?
For math homework, call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net, and social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. Thank you for doing that. So where do you go to school and what grade are you in?
I go to school at Reagan Elementary, and I'm in 5th grade.
How's 5th grade going?
Good.
It could be better though, huh?
Yeah.
How could it be better?
If we weren't in COVID.
Yeah, if we were there, right? It'd be a lot easier if everybody was at school. So you've obviously, I mean, we've already gone through the first half of this year at least, doing everything virtually. Is there anything that you have found easier or you're now more comfortable doing than you did last year?
No.
But you got the hang of it?
Yeah.
All right. What is something that you're looking forward to next school year?
Meeting all my friends.
Seeing all your friends again, huh? Actually in person and stuff like that? Yeah. All right. Well, you know what? We're going to have you start doing some math in a little bit, but do you know what today is? February 2nd?
Groundhog Day.
Groundhog Day, exactly. And that brings us to today's Math in the News. Now, our first bit of news, we need to make sure we know everybody on set. We know that Anjali is here from 5th grade Reagan Elementary. However, we've got a new person on set with us this afternoon, Kyle. Where do you work and what do you do?
I work here at the Kern County Superintendent of Schools office. I'm one of the 2 math coordinators that we have upstairs on the 5th floor.
Right, so you're pretty new to the county as far as that position goes.
Yes. I started in here in October. This is my 21st year in education. I had 13 years at Arvin High School, and then the last 7 years at Kern High School District as the math coordinator.
Okay, and so you work here as one of the math people. So what does that mean? Like, what do you do? I mean, because Anjali's probably like, all right, well, you're a math person here. What does that mean?
Yeah, good question. As math coordinators, we help districts and school sites and teachers and support them in all that they need for mathematics. Give them resources, trainings with professional learning, and just all that goes into supporting math education.
Good. Well, we're glad you're here today. I hope you're ready to do a little math as well.
Let's go.
All right. Well, you know what? As we said, today is Groundhog Day, and out of the newspaper today, we can see they had the little cutouts and things in the background, but it is Groundhog Day. And you can see starting at 6:30 in the morning is when they bring out Phil. All right. And so there's the actual article. I figure let's get a nice close-up of Phil right there. So, hey, you like that? That's a nice shot, huh? A nice little shot right there. So that's our boy Punxsutawney. And there's some people that are like, well, how did this whole thing start? All right. According to the Pennsylvania Tourism Office, Romans brought the early holiday Candlemas to Germany, who concluded that if there was enough sun on Candlemas Day for a badger to cast a shadow, there would be 6 more weeks of bad weather. German immigrants brought this tradition to Pennsylvania, and in 1886, the editor of Punxsutawney's newspaper teamed up with a group of groundhog hunters to begin the legend of Punxsutawney Phil's weather prowess. So that's this whole thing got started. So, you were aware of what happened this morning, right? What happened with Phil?
The groundhog saw its shadow.
He saw a shadow. And what does that mean?
That means there will be 6 more weeks of winter.
Okay. Now, do you think that always comes true, like whatever they say with the groundhog always happens?
Maybe.
Maybe. If you had to give a percent, like 50% would mean it happens half the time, and the other half he's wrong, right? What percent do you think Phil is being correct? You think he's more or less 50%?
Less.
You think he's less? All right, you know what? Let's take a look right here. All right. So here we can see Groundhog Day, February 2nd, and we'll just take the last 10 years. All right. So in 2010, he saw his shadow, right? And there was a bit of weather in February, but not in March. So technically, he's wrong, okay? So we can see in the past 10 years, 40% is how well he's done. So you were correct that he is less than 50%, okay? And we can see, though, that in a couple of past years, he has done pretty well, right? 2011, 13 and 14, he was on a little bit of a roll right there. But then he's missed the last couple of years. So it'll be interesting to see if he gets back on track this year or not. So for those of you playing along with Punxsutawney Phil, estimation, percentages, things like that, and that all is today's Math in the News with Groundhog Day. So, young lady, you are in 5th grade at Reagan Elementary. How long have you been at Reagan?
Since kindergarten.
All right, so you've been there for a long time, right? It's kind of like a home away from home. You've been there for 6 years now. What kind of math are you doing in 5th grade in your classroom right now?
We're just learning fractions and like greater, less than.
Okay, and you feel pretty familiar with those and you feel comfortable doing that stuff?
Yeah.
All right, well, we might get to one of those later on, but you feel pretty good with those. But you're doing some other math on the side as well, right?
Yeah.
So why don't you head on over to the board and explain to us what you're doing with this math problem right here, because a lot of 5th grade students aren't doing this, all right? So if you could explain the problem, and then if you need to, Kyle's right here to help you out if you need any, all right?
Okay, so it says y equals 2x plus 1, and the problem is x squared minus y squared equals negative 21. So we have to substitute x squared minus parentheses 2x plus 1, but we have to square it because the y is squared. So then what we would do is we would have to take out the parentheses.
So before you go, why can you do that? How come you can just make kind of that substitution in there?
Because it says over here y equals 2x plus 1.
So essentially, you know what y equals, so you can make that substitution for another y.
Yeah.
Okay. So what are you thinking about in your head right now as you're doing that computation?
So I'm squaring 2x, which would be 4x squared, and then we would do 2 times 2 times 1, which would be 4. Then we would have to add the x in, and then 1 squared would be 1.
Okay.
So then it would be negative 3x plus 4x plus 1, which equals negative 21. So then what we would have to do is we would have to move this to this side to get rid of that.
So what are you trying to accomplish right now? What's your goal?
So right now I'm just trying to move this so I can figure out the answer to the problem.
Okay, and so why do you need to move that to the other side?
I need to move that to the other side so I can put the negative 21 into one of these numbers so I can put the numbers.
Okay, let's keep going.
So it would be plus 22. So we would have to do this x to get 1 and 3, then 22 factors of 20. The factors of 22 would be 1, 2, 11, and 22. So we have to figure out numbers that would make it equal 4x. So if we were to put 11 here and 2 here, it wouldn't make sense because these two numbers would equal 32 plus 2 would be 35. Could you explain how to do
Yeah,
this?
so you're working on some factoring ideas, right?
Yeah.
Okay, excellent. So are there other numbers you can try there? Instead of that 11 and 2, what if you tried another set of numbers?
We would do 1 and 22 or 22 and 1. So if we did 22 and 1 here, it would be 66 and 1. So if we put 1 here and 22 over here, it would be 3 and 22, which equals 25.
Ah, I see. Now I saw you tried to flip the 22 and the 1 that you flipped. I wonder, what about the 11 and the 2? Have you tried flipping those?
If we were to put 2 here and 11 over here, it would be 6 and 11.
Okay. So what are you thinking right now?
That I should look over my steps.
Okay.
Would you show me how to do this?
Yeah, so let's see. So one thing, let me see if I can I get here somewhere? Let's see, so when you have negative, so what you're trying to do here is factor, correct?
Yeah.
So it appears that you were having a little difficulty factoring this. And so I wonder if there's another method that we might use to be able to solve this type of equation. Let me see. I don't know if I have my pen here anywhere.
Let me try clicking down here for you.
Oh, there we go.
Oh, you got it?
There we go.
Okay.
So let's see here. I'm going to add some in red color here. So when you move this negative 21 to the other side, what's left over on the right-hand side of this equal sign?
0.
Okay, so we have a 0 equal there. Whew. All right, so this, it appears, we were having trouble factoring that using this particular representation that you have here. So is there another way of solving? What type of equation do we have here? Are you familiar with what type of equation this is?
So first, Anjali, so we can clean it up a little bit, get rid of the 1, 2, 11, and 22 underneath there, if you can erase that. And then maybe erase all of the stuff you did on the left-hand side with the 1, 3, and then those other numbers there. And that might clean it up a little bit. And then what you guys can do, I'll move the screen a little bit down. So that way, all right, so I'm going to move the cursor now on you so that you don't, this way you guys have a little more room to work with.
So what type of an equation, when we're looking at this equation right here, what type of equation is that?
A quadratic equation.
And what kind of solutions do we have? What kind of methods do we have for trying to find solutions to a quadratic equation?
Sometimes you can pull numbers out, but I don't see any numbers we can, because 3 is a prime number.
Okay, And so 3 doesn't go into 4, 3 doesn't go into 22, so we can't factor a 3 out, right?
Right.
So is there other methods besides factoring that you're familiar with?
No.
Okay. So if we can't factor something, then when we have a quadratic equation, we could use the quadratic formula. Is that a good idea to try a solution method like that this time?
Yes.
Okay. So let's move back up here. And let's try a quadratic formula. So we have a quadratic formula that says we can find the solutions to any quadratic equation by using this formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Yeah?
Yeah.
So where do we get the a's, the b's, and the c's?
So the -3 would be the A, the 4 would be the B, and the 22 would be the C.
Excellent. So can you make some substitutions and work on that?
Six times 4 would be.
So let's pause for a second. So this first up here is the opposite of what number?
B.
B, okay. So where did this 3 come from?
It came from the A.
Should it be A?
No.
Okay, so maybe can we erase and change and see how we can go further now? Mistakes are perfectly fine. We're learning. So I like how you did the opposite of B. B was a positive 4, so you have a negative 4. I like that.
66 times 4 would be. Minus 264.
Okay, so explain to me how you just got that number.
So I times A and C, which would get -66. So I would put a plus there.
Excellent. And then multiplied by the 4 in front.
4. So it would be 2A. So -3 times 2 would be -6.
Good job. Now how do we keep going?
Then you add with 264, 16, which would equal 280. So you would do -4 plus 280 over -6.
Yeah, great. Now what do you think from here?
Now you have to pull out numbers.
Okay.
So we could pull out 4, which would be 70. So you would have to put 2 here because it's a square root. So you put 2 out, and then you would get 70.
So you're thinking 280 is 4 times 70, and the square root of 4 is 2. So that's where the 2 is coming from?
Yeah.
Okay.
Over -6.
And I'm going to move the screen down for you guys so
Yeah,
you have
yeah,
a little
yeah.
bit more room. So hold on a second.
So if 70 is a prime number, then that would be the answer. But since it is not,
I wonder, are there any more perfect squares that can go into 70 that we might be able to pull out?
no.
What are you thinking? 4,
4 doesn't work.
okay. 9?
No.
No. 16?
No.
No. 16 to 80? No. I think we're 70 is about as much as we can pull out there.
Yeah.
So how can we maybe clean up what's left?
I don't know.
Yeah, so really we have this negative, the opposite of 4, plus or minus 2 times the square root of 70, all divided by 6. And we see a 4 and a 2 and a 6. And what do we see in common here with the numbers?
2.
2, yeah. So maybe we can pull out another 2 and factor out another 2.
So we could do 2 parentheses negative 2 plus minus root 70 over negative 3.
Okay, yeah. And so we can't forget that, that pulling out that 2, excellent. So we can't forget that all this was equal to x, right?
Yeah.
So all this was equal to x. And we can clean this up a little bit if we wanted to as well. The 2's divide out. We have a 2 as a factor on the top and a 2 as a factor on the bottom. So those 2's will kind of divide out there. We can simplify that out.
Yeah.
So really, we're left here with the opposite of 2 plus or minus the square root of 70 divided by negative 3. And from here, we might be able to clean it up even more with negatives divided by negatives. Or we might just consider to leave it there. There's nothing wrong with leaving an answer like that either. So now we have a solution for x. How does that help us in the original problem?
Maybe we could plug it in.
Yeah, we might be able to now take some of that, plug it in, and figure out kind of our answer for y.
Yeah.
We've gone down the rabbit hole now, right?
Yeah. I was going to say, do you need me to scroll back up?
Yeah, I think we're going to need that original problem, right?
Right, so let me scroll back up so you guys can see a little bit of that.
So now we know that we have an answer for x. In fact, we actually have 2 answers for x, right?
Yeah.
Yeah, so now we can think about that. How is that going to, how are we going to maybe be able to figure out an answer for y now?
Well, we do have an answer for y. It's just that we have to figure out another answer for x.
So what's our answer for y then?
2x plus 1.
Ah, yeah, 2 times x plus 1, right? Only if we knew the value of x, oh, it would be so great. We'd be able to figure out the value of y, right?
Yeah.
Do we know the value of x?
Yeah.
Yeah, I think we have it down at the bottom, right? I think it was, what, 2 plus or minus the square root of 70 over 3?
Yeah.
Do you think we could use that to figure out y?
Yeah.
Awesome. You want to give it a go?
So yeah, if you want to erase some stuff so you've got some more room to work.
So it would be 2 times.
I think it was, what, 2 plus or minus the square root of 70 over 3? Is that correct?
Let me scroll down real quick for you guys if you want, and then I can
root
we can make sure once you write it.
70 over negative 3.
All right, so I'm going to
plus
scroll down,
1.
Anjali, just real quick here to make sure that that is what you guys have. There we go.
I think you got it. Scroll down, got that answer for x. So remember, I think what we're figuring out here is a solution for y, right?
Yeah.
So what do you think? Is there anything we can do up there?
We can multiply it all in.
Sure.
So 2 times negative 2 would be negative 4 plus 2 root 70 and negative 6, which was what we already had, but we pulled the 2 out.
Yeah, absolutely. And then what's tacked on the end there?
70
What about this guy right here?
plus 1.
Yeah, we can't forget about that guy. And all that's equal to what?
Y.
Yeah. So we could keep going and we could keep going and we could keep going to get an answer that's more simple and more simple, or that looks a different form than this. We can get a 1 here and keep going. Or we can say, you know what, this is an expression that represents the answer for y. It's a numerical expression, and if I worked it all out, I'd get that answer for y, just like I would work it all out and get the answer for x. So we've gone through this system to tackle and find a value for x. We've substituted that back in to find the answer for y, and we could keep working these out. How far do you want to go with this?
Well, at this point, we're going to stop at that point.
Okay.
And you guys keep working in a couple of moments, but right now, that was an excellent first problem for the both of you. So Anjali, nicely done on that. So there was a little bit of stuff where you guys worked together on that. Kyle, great problem for your first one on the show as well. But Anjali, for doing a great problem, you've got yourself a meal, courtesy of our friends at The Broken Yoke. So congratulations on that. Hopefully you get an opportunity to go over there and enjoy your meal sometime. And we'll be back with more right after this. Well, today we've got a variety of 6th grade students from around Bakersfield. We're at the KCSOS building, and today we're going to work with America's pastime. Some say it's baseball. They're correct, all right? So, each of the students has an enlarged baseball card, something a little bit bigger than the normal sized baseball card. So go ahead and flip it over and see if that's a little bit easier to read the stats on. You think that's a little bit easier? Mm-hmm. And indeed it is, right? So we're going to work on taking a look specifically at some of the stats and then working on possibly creating a circle graph based on those stats. So the first thing we need to do is on the paper, let's take a look at it. And we can see there's a few things we're going to make. We're going to make a ratio. Instead of calling it a ratio, if I have one number over another number, what would we call that?
A fraction.
It's a fraction. It's also a ratio, all right? The next thing we have is a decimal equivalent. So what will be in the answer? A decimal, right? It's going to be the decimal equivalent, right? And then the last thing we have is a percentage. So fractions, decimals, and percents are things that all students are working on a lot, starting especially in 5th grade and 6th grade. And as you get through junior high, you're going to be using fractions, decimals, and percents even more. And we're going to go in even one more step. And we're going to figure out degrees with this also, all right? So the first thing we need to do is the first column is PA. Now look on the back of the baseball card. Is there any column that says PA? And PA is going to stand for plate appearances. Can anybody find where PA is? Does it even exist? Is it on there anywhere? No. So we need to figure out what PA is. Plate appearances is how many times they go up to bat. So is there AB, is there at bat anywhere?
Yes.
Okay. So we're going to look at the year 1994. Okay. So 1994, what was the AB? What were the at bats in 1994?
433.
433. Okay, so we're not going to put it in there yet. That's going to be one number. The other number that we add to it is BB, base on balls or walks. So we're going to take AB and BB and add them up for 1994. So when you add them up, the AB and the BB for 1994, what do we get? So 489, okay? So on your paper, under PA, you're going to write 489. Okay? And we could look at a lot of different stats, like how many times they got on base, second base, third base, or we could look at home runs. What do you think is the most exciting one?
Home runs.
Home runs, right? So how many home runs were there in 1994 for Ken Griffey?
40.
40. So under HR, we're going to put 40 right? So we can put 40 in there. Now our ratio is going to be our fraction. So we had 40 home runs out of how many plate appearances? 489. So we're going to write 40 over 489. Okay? So on your paper, we've got 40 home runs. And so we're going to have 40 over 489. And you guys have a little larger boxes to write in. Now we want the decimal equivalent. So I'm going to go 40 divided by 489. Okay, so you've got calculators, go ahead and do that. 40 divided by 489. And did anybody get a decimal equivalent yet? Okay, so we're going to go 4 places. All right, we're going to go 4 places. So if we round it 4 places, what would that number be? 0.0818. Right, 0.0818. All right, so put that in there for your decimal equivalent, and we'll figure out the rest of the percentages and degrees when we come back next time with the students at KCSOS. And once again, a big thanks to all of those students that had the opportunity to come to KCSOS and do a little bit of extra math work with us right there. And always nice to do some baseball math, since baseball will be coming up soon, the beginning of the regular season. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year, as we do this week. And before we get going with our next special guest in studio, Anjali and Kyle find a little mistake that they were working on last problem, so they're going to clean this up really quick and explain what happened on that problem.
Yeah, as we were going by, we realized that wasn't looking the way it should, right? So we went back and looked at our work, and Anjali, why don't you explain kind of where we went wrong there?
So what we forgot to do wrong is that we forgot to multiply the negative symbol.
Yeah, so real quick, can you show us how that looks when you do that?
It would be negative 4x squared, negative 4x, negative 1, which would equal negative 21.
Yeah, and I think there now, if we continue to go down that path of combining some terms and setting an equal to 0 and looking at the factoring, I think it'll flow just swell from there.
There you go, nicely done. So glad that you guys were able to catch that mistake and keep going from there. All right, Anjali, are you ready?
Yeah.
Why don't you head on over to the table, because right now we have some guests from the Panama-Buena Vista Union School District Visual and Performing Arts Department. Ladies, how are you today?
Wonderful, thanks.
Nice to see you. Why don't you let everybody know where you work, the schools that you're at, if you're at more than one or if you're just at one.
I'm Audrey Boyle, and I work at Warren Junior High School, and I teach orchestra and chorus.
And I'm Lucy Adams, and I work at McAuliffe Elementary and Van Horn Elementary and teach instrumental music, band and strings.
All right, well, ladies, we thank you for being here today, and you've got Anjali, a 5th grade student from Reagan, to help you out. So take it away.
Good afternoon, everyone. We're going to start out with a little bit of review. We know that you met Miss Rizzo and Miss Wright last month, 2 other music teachers in our district, and they talked about how math and rhythm are related. So we're going to come over here to this side of the board and do a little note value review. This is what they went over last time. So just in case you weren't here with us, they talked about whole notes, and they look like this, and they're worth 4 counts. And then half notes are a whole note with a stem, and they are worth 2 counts. And then quarter notes are half notes that are colored in, and they are worth 1 count. And then eighth notes, when we have 2 of them together, look like this. But if we were together and we were joining hands like that, or joining shoulders, if you can imagine, we don't want to do this right now because we're social distancing, but when you cut the tie and the arm falls over like this, it makes this little arm right here, and it's an eighth note, and it is worth only a half a beat. So using these different whole notes, half notes, quarter notes, and eighth notes in a context of 4 beats per measure, you can see that the whole note, if we were to count, would be 1 and, 2 and, 3 and, 4 and. We've got half notes where we've got 2 beats plus 2 more beats. So we get 1 and, 2 and, 3 and, 4 and. Then we've got quarter notes, which are 1 beat each, so it's 1 plus 1 plus 1 plus 1. They still always have to add up to 4 in this example. So we've got 1 and, 2 and, 3 and, 4 and. And then down here on the bottom, we've got 8 eighth notes, and we clap every time we say something, and it would look and sound like this: 1 and, 2 and, 3 and, 4 and. Okay, now I'm going to turn it over to Mrs. Adams.
And today we're going to introduce the time signatures. Looks just like a fraction, but it's not. And it looks even more like a fraction when it's actually on music, because this note goes on top of the first 2 lines, and this goes under the line. So it looks like there's a line in there because there's a line on the staff, but it's very different than a fraction. The top number tells you how many beats are in a measure, which is like a musical sentence, and the bottom number tells you what kind of note gets 1 count. You can have a 4 on the bottom, you can have a 2 on the bottom, 1 on the bottom, an eighth note on the bottom. You can have all these variants on the bottom. These are bar lines, and bar lines are like periods kind of. They separate music into measures. So if you have 4/4, it means within one of these measures there are going to be 4 beats. But boy, there are a bunch of different ways you can make up 4 beats. The double bar line tells you it's the end of a piece of music. So before we get into where you start clapping and counting and we do some fun, let you do some guessing games today, I want to talk about the 3 beats in a measure, 3/4 time. Since there's an odd number, this is a little tricky. You know, it's easier when it's an even number. When the top number is odd, it gets a little strange sometimes. So if they want to have just 1 note in a measure, you can't really do that because you only have the half notes and the quarter notes and the eighth notes. When you have a dot after a note in music, it gives it its value plus half its value. So Anjali, can I let you try to answer a question? So if a half note gets 2 beats and the dot gives it its value plus half its value, how many beats would we have in a dotted half note? So 2 plus half of 2.
1 would be 3.
3 beats. Okay, so the dotted half note gets 3 beats. 1, 2, 3. And that happens anytime you have a dot. After a quarter note, it's kind of tricky. That's when the division really starts in music. Okay, so let's try clapping and counting. Mrs. Boyle's going to play with us. And Anjali, will you help us clap and count? We're getting you all ready for band or strings next year because we really want you to be in it. So let's go ahead and we'll get you started. So we're going to try clapping and counting. This Miss Boyle's going to play it with us. Okay, ready? How many beats are in a measure here?
4.
What kind of note gets 1 count? A
Whole
quarter note. Yes, all right. Here we go. Ready, set, here we go. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and yes. This one is 3/4. So there are how many beats in a measure?
3.
3. So we only get to count to 3 this time. It's going to feel a little different. Let's try this one. Ready, set, here we go. 1 and 2 and 3 and 1 and 2 and 3 and 1 and 2 and 3 and yes. Then we have 2/4. How many beats would be in a measure in 2/4?
2.
2. All right. Here we go. 1 and 2 and 1 and 2 and 1 and 2 and. All right. Thank you, Ms. Boyle. It sounds beautiful. 6/8 is fun. 6/8 is kind of tricky, though. We have 6 beats in a measure. The eighth note gets 1 count. If there are 2 eighth notes in a quarter note, this would be like 2 eighth notes. What's half of 2?
1.
1. 2 plus 1 is 3.
3.
So this would get 3 eighth notes or a beat and a half. If it gets a beat and a half, if it were a quarter note with a dot, it would be a beat and a half. In this case, because the eighth note is the value, there are 8 beats in a measure. Let's try this real carefully. Let's practice it one time, okay? So this would get 3 beats. Ready? Go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And when you hear strange music, sometimes they're playing around with where those notes fit in with the rhythm. Okay. You're going to do okay. This one's getting more complicated. We're going to play a game soon with all of these. Okay. 5/4, there are 5 beats in a measure, another odd number. This will feel pretty strange. Let's try doing the first one. Ready, go. 1 and 2 and 3 and 4 and 5 in. Okay. When you see this little thing under a note, it gives it what's called an accent. So you give it extra oomph. A lot of times when you see dancers, they're stepping on that accent, really having a good time. So we're going to try this one, and you want to clap really loud when you see the accent, but still count to 5. Ready, set, 5, go. 1, 2, 3, 4, 5. Sometimes when you're playing music, a conductor will conduct 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. But it's still the mathematical equation, which is just like in math. 2 plus 3 equals 5, or 3 plus 2 equals 5. Let's try doing the 2 plus 3 equals 5 and counting it 1, 2, 1, 2, 3. Ready, together, go. 1, 2, 1, 2, 3. Okay, and let's try this one, counting it 1, 2, 3, 1, 2 with the accents. Ready, go. 1, 2, 3, 1, 2. Or you could count to 5 in every measure. Okay, and we have one more before we play the game. This is 7, 8. So how many beats would be in a measure here?
7.
7 beats, okay. You have equation 3 plus 2 plus 2 equals 7, right? Okay, thank you. 2 plus 3 plus 2 equals 7, or 2 plus 2 plus 3 equals 7. Let's try doing these variations. This would be a 3 plus 2 plus 2. Ready? You can count to 7 if you're if you're watching this, or you can count by 3 and 2 and 2. Ready, set, go. 1, 2, 3, 1, 2, 1, 2. Next one, ready, go. 1, 2, 1, 2, 3, 1, 2. Next one, ready, go. 1, 2, 3, 4, 5, 6, 7. Okay, now we want to play something and see if you can figure out from feeling it which one of these rhythms we are in. If you feel 6 beats, 4 beats, 2 beats, 5 beats. So if you're out there watching, you try to guess too. We're going to try doing this. Whoops, got to switch this.
We have special PPE, personal
Yes.
protective equipment masks, for our teachers who play instruments, and also for our trumpet, even PPE for our instruments.
Okay, so here we go. I want you to listen carefully and see if you can figure out what the time signature is. You want to guess? Which one do you think it is? 2, 4, 3, 4, 4, 4? I'll give you a hint. It's one of the first 3. And 2 of the answers would kind of be right because they're very similar.
2.
2, 4. You got it. Good job. Okay, here's the second one. It's either 3, 4 or 4, 4. What did you feel if you were stomping your foot?
4, 4.
You're real close. Listen again and see. So if you count with it, what would you?
3, 4.
Yes, 3, 4. Very good. And since we're almost out of time, let's skip to one of the harder ones here. Okay, let's skip to this one. It's on the right side. This mask has stuff in it. I'm sorry. Okay.
Five, 4.
Oh, you're so close. Just one more time. 1, 2, 3, 4, 5, 6. 1, 2, 3.
6, 8.
6. Good job. Okay. And one more. We'll do the hardest one. Okay. Sorry. You want to take a guess?
5, 4.
It was very close. So we think 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So Angela, you have been wonderful. We can't wait to have you in the music program. And we want to thank you all very much. You did an awesome job. You were just exactly the kind of music student we want. And see how much math we get to do in music? Yes.
There you go. Thank you very much, ladies. Thank you for taking some time coming in today. And also thank you to Anjali for going over, volunteering, and learning a little bit about math and music together. We do have phone tutors available until 5:30. We'll be back with more right after this.
I'm Buffalo. I'm here in Montana at Earl State Park. I just want to ask you guys a couple of questions. Do you notice anything unusual about the plants behind me? Have you ever seen anything like them in your neighborhood? Today we're going to talk about one of California's most important ecosystems, but one that's really little understood. I'm talking about Chaparral. Chaparral comes from the Spanish word chaparro, which means small or dwarf size. And most plants that you find in the chaparral are small. They don't grow up to be large trees like pine trees or sequoia redwoods, which you might find in the Sierra Mountains. Now, California's forests, their national forests, cover about 3.5 million acres of land in mostly Southern California. And it's also home to over 300 species of plants and animals. In fact, San Diego County, the home of Cleveland National Forest, is the most biodiverse area in the United States. California chaparral ecosystems have suffered tremendously from human activity, primarily from housing developments, utilities installations, and highway installation. There are over 5 million housing units within the chaparral, which makes fire prevention and too frequent fires a major problem. Many people don't know that Chaparral provides California's 22 million residents with ecosystem services or natural benefits that are important to our daily lives and vital for our health and survival. Chaparral is a very important source of carbon storage. It takes up something like 26 million metric tons of carbon every year. That's equivalent to the emissions from 20 million cars annually. While taking up carbon dioxide, Chaparral also provides oxygen for us, which is a natural benefit. We also derive a lot of our water from Chaparral. In fact, enough water from runoff and recharge, which is the water that sinks into the ground and becomes part of the aquifer, supplies enough water for all California for 100 years annually. Chaparral vegetation holds soil and rocks in place, which prevents erosion of the hillsides after heavy rains. 17 million tons of sediment is trapped by sediment dams each year, enough to fill 130,000 swimming pools. Over 7 million people use California's national forests every year for recreational purposes. Over time, chaparral vegetation has adapted to a fire regime that varies between 30 and 50 years or so. There are certain chaparral vegetation whose seeds only sprout after a fire, as a matter of fact. The problem that we have right now is that the fires are too frequent, which doesn't give the chaparral time to recover. And so in its place, wild grasses grow, which don't hold soil and they don't prevent mudslides like chaparral vegetation does. It's time you gaze at the hillsides to enjoy the wildflowers, or you travel to a national forest, or simply pour a glass of water. Remember, Chaparral is your friend.
Always a lot going on over at Camp Keep. And Anjali, since you're a 5th grader, next year when you're in 6th grade, hopefully you have an opportunity to go visit and partake in all of the activities at Camp Keep. We do have phone tutors available until 5:30. We've got Kyle in studio with us, helping us out as well. He's one of the, is it math coordinator?
That's correct, yes, math
Okay,
coordinator.
for the Kern County Superintendent of Schools. Right now we're going to go to the phones, and we've got an 8th grader. Shacey, how are you today? Hello?
Hello?
Yes. Are you ready to do your problem?
Yes.
All right. Take a look on the board and make sure that we've got it written down correctly, and then you can go ahead and start on it. Is everything correct?
Yes.
All right.
Excellent, Shasi. So how would you think about starting this?
I'm good. How are you?
Great, excellent. How would you think about starting this problem? What are you thinking about as like a first step to solve the problem you have this afternoon?
I don't know how to start it.
Oh, okay, excellent. So let's see. What if I covered up this right-hand side here? Would that help at all? I mean, is there some operation you know that happens between a number outside of parentheses and a number inside?
I don't think so.
Okay. Whenever we have this, remember, this represents 5 times this parenthesis. So really we have 5 of these b plus 5s, this quantity here. So if I was going to take b plus 5, and I was going to have b plus 5 plus b plus 5 plus b plus 5 plus b plus 5 plus b plus 5. How many is that? 1, 2, 3, 4, 5. If I was going to add that quantity 5 times, what do you think? How many b's would I have? How many b's are there?
5.
Excellent. So we've got 5 b's. And then let's see, I have 5 plus 5, that's 10, plus another 5, 15, plus another 5, 20, plus another 5 gives me
25.
25. Excellent. So we can see here that if I have b plus 5 times, I end up with 5b plus 25. So one way to think about it is there's this distributive property that says, well, you know, I could multiply 5 times b, and I can multiply 5 times 5. But really that distributive property, what it means is add those up 5 different times. So I have b plus 5. Let's bring down the 3b. And all that equals 65.
And I will give you 90 seconds to complete this.
Excellent. Excellent. Here we go. So if I have 5 boxes and I want to add 3 more boxes, how many boxes do I have? So let's see, 5 boxes. We're adding 3 more boxes. That should be a total of, what do we got, 8 boxes?
8 boxes?
Yeah, 8 boxes. Plus I have my 25. And that's going to equal the 65. What about from here? You think you can give a go of the solutions here? If I have 8b plus 25 equals 65? Let's see, we have a number times 8, and then I'm going to add 25 to that to give me 65. What do I think? This 8b, what plus 25 gives me 65? If I can subtract that 25 from both sides, that means this 8b, sure enough, should equal 40. And what do you think? What times b gives me 40? What number times 8 gives me 40?
5.
Yep, there you go. So there you have it, b equals 5. But you can see the step kicking off there was we want to make sure that we distribute, and then we can combine our like terms and finish out the problem from there.
There you go. Nicely done. Jason, thank you for that call and for calling in with that problem. You've got yourself a meal courtesy of our friends at Grillenberger, so congratulations on that. Well, you know what? The Mars rover Perseverance will touch down on the surface of the red planet Thursday, February 18th around noon Pacific time. Its mission, in part, is to gather soil for testing as scientists search for the answer to the big question. Has there ever been life on Mars. Well, Do the Math is counting down the days to the big STEAM event with special coverage. We go behind the scenes to see how this mission came together and what we can expect from Perseverance once it lands on Mars.
We are working on something that is the cleanest we've ever really attempted to send into space.
The Perseverance mission has as its central goal astrobiology and also being the first step in Mars sample return. We're going to collect a suite of samples, about 35 samples, that each weigh about 15 grams.
And the reason we collect those intact samples is that we are the first mission that's part of Mars sample return, and it's our job to collect the samples intact to be brought back to Earth for further analysis.
To better assess the question of, was there life previously on Mars? Inside the belly of the rover sit a number of sample tubes and an entire adaptive caching assembly that is used to help collect these samples.
Extraordinarily complex robotic system. And to make it even more complicated, it has to be super clean. We don't want to have these samples come back from Mars and discover life in them, but then realize, oh, that's life that was in the apparatus when we sent it to Mars.
That was a big challenge for the mission because we were meeting cleanliness standards that no rover mission has ever had to meet before.
The requirements that we have for this mission are extraordinarily challenging.
Once we would go through machining the tube itself, getting all of our protective coatings on there, and then looking at our beautiful tubes, we found carbon contamination in places we were not expecting. So as a team, we all had to really come together and look at the entire manufacturing process, how we're handling these tubes. We had to start polishing the interior bore prior to putting on some of our protective coatings.
It meant having to come up with an entirely new technique to clean all of the hardware and demonstrate that the hardware could maintain that cleanliness all the way to Mars.
That's what JPL does. I mean, we discover problems and then we solve them.
Having these very strict controls and this record of how much contamination or how clean these tubes are prior to going to Mars is essential for that return sample science.
Great discoveries require remarkable evidence, and so the cleanliness of the sample tubes and of all of the hardware that's going to be collecting those samples is paramount in making sure that the evidence and that the story and that the discoveries that come from these samples that are brought back are irrefutably Martian.
Well, Perseverance touches down on the Martian surface Thursday, February 18th around noon. Live coverage of this special STEAM event begins at 11:45 a.m. right here on KETN, a service of your Kern County Superintendent of Schools office. So something forward looking to February 18th. Maybe you guys can check that out. It'll be happening during the lunch hour while most of us are in school, so we can check that out. Anjali, you did some excellent work today. Did you learn a little something?
Yeah.
Good. Did you have fun with the music over there as well?
Yeah.
That's always something, you know, when they come in and you can apply math to a lot of different areas and things that we've never even thought of, right? So hopefully you get into band or chorus or something like that or orchestra next year and you can apply some of that. We do have phone tutors available until 5:30 this afternoon. Kyle, thank you for coming in this afternoon. Your first time on the show. We expect to see you more often now. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama-Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.